All right, so today we're going to talk about acids and bases, part number one. So we're going to cover the pH scale and then how to do pH problems. So this first slide here has the pH scale on it. And you can see that the pH scale can hold a wide range of chemicals from the incredibly strong, like batteries, which are incredibly strong acids that if you were to drink battery acid, you would die. And then we move over to things we consume on an everyday basis, from lemons all the way over to egg whites. Stomach tablets would be like antacid tablets that some of you may consume, or your parents, all the way over to the very, very strong bases, which again, if you were to consume bleach or drain cleaner, that would also cause you to die. So how pH is divided up is it looks at the concentration of the hydrogen ions that you have compared to the hydroxide. So when you have a low pH number, 7 or less, that indicates there are more hydrogen ions that are in solution. If you have a pH number that's 7 or higher, or I'm sorry, above 7, that's going to be a base, and you're going to have more hydroxide in that. So again, high amounts of H plus ions are going to be acids and low. High amounts of OH will be bases with high pHs. So how we actually get a hydrogen ion or hydronium is that every once in a while, two water molecules will collide together. And what will happen is that one of the H's will pop off of one of the water molecules and go to the other one. So you can see there's two water molecules coming here, and then one of the H's from one of the water molecules leaves this and then goes on to this item to get us H3O plus and then OH minus. As I indicated, below 7 on the pH scale is going to be acidic. Above 7 is going to be basic. And then the further from 7 that you go, the stronger the acid or base will become. So when you look at this here, neutral is 7, acidics goes this way, bases go that way. We talked about this on the previous slide with that water ionization, that you get two water molecules that come together, and then that's going to get us this H3O plus and this OH minus. And then the Kw of water, which we'll talk about a little bit later, is going to be 1 times 10 to the negative 14. This is why pH, neutral pH is 7. That's always a question that students have, and it's totally reasonable. Like most things, you start off with 0 or something similar to that, where pH, it's interesting that neutral is 7, and it is 7 because of water. So when you have distilled water, you have basically 1 times 10 to the negative 7 concentration or molarity of the hydronium, and that's also the hydroxide concentration. So when you plug that into the pH equation, negative log of that will get us a pH of 7. So that's why that neutral pH is 7. So let me go ahead and show you the other unique thing about pH is to get everything to fit on there is that instead of going up by units of 1, it's a logarithmic scale. So you go up by a pH of 1, it's going to be 10 times more acidic or basic. And so the lake moves from a 5.9 to a 3.9, it's 100 times more acidic than the previous lake. So to give you guys an example of this, I use the classroom and distance. So instead of pH units of 1, we'll move 10 meters. So with the classroom, and by the way, I don't know if you guys remember what it looks like because it's been about a month, but this is the door to my classroom. You can see the corner over there. And so if the pH of 7 is right at our classroom, pH of 6 is going to be 1 meter outside the classroom, or you can see it's going to be right here. pH of 5 is going to be 10 meters, and that'll put us on the other side of going toward Mr. Pashto's room. That puts us on the other side to the main hallway, and then we're basically facing his door. pH of 4 puts us 100 meters away. 100 meters from my classroom going west puts us roughly at the entrance to Hillside. pH of 3, which is 1,000 meters, and that's roughly 90th and Western. There was no good landmark there, so I just put that New Kessel retirement community. pH of 2 being 10,000 meters. 10,000 meters from Prep going west puts us at about to Boys Town. pH 1, 100,000 meters away, puts us down in Lincoln, roughly at Memorial Stadium. pH 0, which is going to be 1 million meters away, puts us in about Aspen, Colorado. And if we were to leave Omaha and drive to Aspen, it would be about a 10-hour drive from Prep to get to Aspen. And then pH of -1, if we keep going west, gets us all the way to Tokyo. So that would put us in 10 million meters from Prep is about pH -1, and that would put us roughly in Tokyo, Japan. So this item here is going to be crucial and important. This is the pH map. So make sure that you recognize this pH map, know this pH map, and utilize this pH map to make this work. We're going to be doing different steps on the pH map, and that'll go along with the homework set you guys will need to work on for after Easter break, and as we keep moving forward with acid bases. So basically, I have a series of problems. These are 5 problems. We're going to work through all 5 of these. So the first problem is, what's the pH of an acid with an H plus of 3.0 times 10 to the -8? So what's going to happen is H plus is here, and we're going to pH down here. And the pathway to get from here to here is negative log of H3O. So what's going to happen is pH will equal negative log of H plus. pH will equal negative log of 3.0 times 10 to the 8th molarity. And that's going to get us a pH of 7.52. Usually when students make mistakes on acid bases, there's 2 major factors. Number 1, they make a mistake when it comes to using the chart correctly, the pH map correctly. Or 2, it's a calculator mistake. So again, make sure you know how to use your log keys and those type of stuff to make this work. So question number 2, what's the H3O plus of an acid with a pH of 8.5? So if the pH is 8.5 and we're going up to H3O plus, that's going to be 10 to the negative pH power. 10 to the negative pH power is 10 to the negative 8.5, which is going to be 3.2 times 10 to the negative 9 molarity. And so what you're going to do is above the log key, there should be a 10 to an x key. 10 to the x is the inverse key of log, similar to like addition and subtraction are inverse functions, and so is multiplication and division. So log and 10 to the x are also inverse. So you need to use that 10 to the x key for there. You'll have 10 to the negative 8.5 power. That'll get you 3.2 times 10 to the negative 9. For the third one, what's the pOH of a base with an OH of 4.0 times 10 to the negative 6? Well, this is our OH here, and we're going to pOH down here. So how are we going to accomplish that, and how are we going to get that? So you can see the pathway to get from here to here is going to be negative log of OH. And so I'll have pOH equals negative log of OH, and then pOH is negative log, and then the value is 4.0 times 10 to the negative 6. So pOH is 5.40 for that. For the fourth one, we have what is the H plus of a base with an OH of 4.0 times 10 to the negative 6. OH is here. H plus is here. We're moving in this direction right here. So it's going to be Kw divided by the OH minus concentration. That's going to make that work. And then what's going to happen is the KW I gave you very early on in this presentation is 1.0 times 10 to the negative 14. And then the OH concentration is going to be 4.0 times 10 to the negative 6. So when you take 1.0 times 10 to the negative 14 divided by 4 times 10 to the negative 6, that'll be 2.5 times 10 to the negative 9. Molarity will be the H+. What is the pH of a base with an OH of 4.0 times 10 to the negative 6 molarity? So we're starting off here with OH, and we're going to here, which is pH. So there are two pathways to go to get that. Pathway number one, you go in this direction over here to get H3O, and then you go down to pH. Pathway number two, you do negative log of OH to go down here, and you take 14.0 minus POH here to make that work. I have found that going down and across is the better pathway because a basic subtraction problem is much easier to do than this problem up here where you're dealing with exponents and division, and there's just many more errors that you can have. So normally when I have to do two-step problems, if it's going through from pH to POH, I'll normally take 14.0 minus that. So for the first step, we're going to go to POH. So negative log of OH will get us 5.4. Then to get pH, you'll take 14.0 minus the POH. So 14.0 minus 5.4 gives us a pH of 8.6. So here's three additional problems. H plus is 9.5 times 10 to the negative 4. What's the OH concentration? And the H plus is 3.0 times 10 to the negative third. What's the pH? And OH is 1.5 times 10 to the negative 8. What is the pH? I'll let you guys to pause the video at this point and try to do these on your own, and then restart it, and I'll have the answers on the next slides along with explanations. Okay, so for number one, the answer comes to get 1.1 times 10 to the negative 11th. Number two, the answer is 2.5. And number three, the answer is 6.2. All right, so we'll do some more work with this in class and also on Canvas. That is it for acid bases number one. I know I gave you guys a lot. We'll definitely spend a couple days on this before we do some of the more finish up with the conceptual pieces to acid bases.